Okay, we are going to do for today homework for chapter 5 on quadratic equation and graph. Okay, this one you already done question 1 all the way to question 9 yesterday. Today, very simple, we are just doing these last 3 questions. Okay, number 10 can be found in your textbook, and these 2 questions can be found inside this worksheet which was given to you some time ago. Okay, you turn to the very last page of this worksheet, exercise 1C. Okay, the question number 2 and number 3 will be what we are doing. I've already cut the questions out, so we'll be doing it later. Okay, now before I do the 3 questions, I have to go through with you some basic stuff. Now, do you remember when we were doing chapter 1, we have something like that, solve simultaneous equations. Okay, then they give you solve simultaneous equations, and then they give you maybe 2x minus 5 equals 32, so you call this equation 1, and then you call this equation 2. Now both of these, notice that they are straight lines. Why are they straight lines? Because if I were to express this in the form y equals mx plus c, I would end up with 2x minus 32 equals 5y. Then I divide throughout by 5, I will end up with y equals to 5 over 2x. That's your mx. Then minus 32 over 5. That's your c, right? Okay, of course, after that, you just reduce them to your mixed numbers and all that. Same here, I can change this into y equal mx plus c, and I will end up with y equals to minus 2 over 3x. In this case, there's no y-intercept, okay, meaning this line will pass through the origin. Alright, now if I were to ask you to solve these 2 equations, what I'm asking you to do is to find the unknown x and y, meaning to say at the end of your working, you need to tell me what's the value of x and what's the value of y. Alright, now just very fast forward. Okay, we can use elimination, and we can find your y, we can find your x, and this is your final answer. Now, by using this method, you are using algebra to solve these 2 simultaneous equations. Okay, and specifically in this question, I've used elimination. You can also use substitution and you'll get the same answer. But there is another method other than algebra which you can use to solve this equation if the question actually asks you to use graph to solve, and that is to use graphical method. Alright, meaning to say that, okay, these 2 equations are the same as what you had seen earlier. This can be found on page 49 of your textbook. If you want, you can refer to it. I have this line, straight line we discussed earlier, and I have this straight line we discussed earlier. You just choose any 2 or 3 points, alright? Many of you are still quite confused how I get all these numbers. As mentioned, you can choose any number that you see on your scale here. For example, the question asked me to draw from minus 10 to 10, from minus 10 to 10 for the y-axis. I can choose any x value that I see here. So most of the time, I like to choose 0. And I can choose 5, I can choose minus 5, up to me. Okay, but for this particular example in your textbook, they have chosen minus 4. So they put x equals minus 4 inside here. They manipulate and they will be able to get y equals to minus 8. Same for this, they put x here, they will be able to get y equal minus 6. And same for the last one. Alright, that's how they get these 3 points. They draw a straight line through, okay, from here minus 10 all the way to 10, and that will be the line 2x plus 3 equals 0. 2x minus 5y equals to 32. Alright, sorry, I was referring to the wrong line here. This line, just now it was this, okay, this line here. This line is this line. Okay, now notice that the intersection of these 2 lines here actually give you the x value, which is 6, and the y value when you draw it horizontally, which is minus 4. Okay, it's the same as what we've obtained earlier using algebra, if you remember. Okay, x is 6, right? Y is minus 4, y minus 4. Okay, so we can either use graphical method this way, or we can use algebra. Okay, so that was what we learned in chapter 1. Now in chapter 5, we are going to do the same thing, almost the same thing. It's just that we, instead of using two straight lines, we are going to have a curve and a straight line. Okay, so you can do the same here. For example, I asked you to solve these two simultaneous equations. Y equals to minus x plus 4, that's one equation, and it's a straight line. Okay, it's a straight line. This is a curve, this is a straight line. Okay, then how do we solve this? We can use algebra to solve this. It is the same thing, alright? This is y equals this is y equals this, so I can sub 1 into 2. And I'll get this equals to this. Okay, now remember how to solve quadratic equation. Your right hand side must be equals to 0. Right now it is not equals to 0, so you have to make it become equals to 0. Now how do we do that? We don't want minus x on the right here, so we plus x on both sides. Okay, we plus x on both sides. Let me look for, okay, never mind. We plus x here, and not here, but we plus x here. Alright? So that this x will disappear, and then you will have another x on the left hand side. Now, do I want the 4 on the right hand side? No, I don't want the 4, so I minus 4 on the right as well. If I minus 4 on the right, I must minus 4 on the left. Okay? Now effectively, whatever I've done just now by adding x, minusing 4 on both sides, I have actually removed the right hand side, whatever terms is on the right hand side. So now the right hand side has become 0. Okay? Now how about the left hand side? The x square remains the same because I didn't add or subtract any x square. I didn't do anything to the x square, so it remains the same. But minus 2x plus x will now give you just minus x. If you don't know, you just press calculator, minus 2 plus 1. This is 1. You get minus 1, and that's minus x. Similarly, for the constant term, 2 minus 4 will give you minus 2. Okay, if you don't know, press calculator. Now, this equation here, okay, is actually what you need to solve now in order to obtain the value of x. That means if you were to solve this equation here, okay, this equation is equivalent to these two combined together. If you were to solve this equation here, you will get the answer for x here. Okay, so using your calculator, you press 1, minus 1, and minus 2. And that will give you 2 and minus 1. Alright? 2 and minus 1. So you work backwards. This will be x plus 1. This will be x minus 2. Okay? So you've gotten your x value already. Now, some of you may be wondering, how come there are two answers? Now, there are two answers because this is a quadratic equation. So there'll be two answers. When you do linear equation, meaning a straight line, right, you only get one value of x. But for quadratic equation, you can have two values. But sometimes the x value may be the same. It may be x equals to 2, x equals to 2. So that's what we call a repeated root. By the way, this is called a root. This is also called a root. Okay? You need to know this term root. It's actually just the solution or the answer to the expression, the equation here. Now, what I need to do next is also to find the y value. Because when I ask you to solve this equation, you need to find the unknown, and there's one unknown x and an unknown y. So you need to find x and y. And when x equals to -1, there is one y value, okay? When x equals to 2, there is another y value. This y value and this y value, you can see they are different, all right? Which means that this is actually one point, and this is another point. But of course, when they ask you to solve like that, right, you don't give the coordinates unless they ask you for the coordinates, meaning they ask you, at which point will this line cut this line? Okay, at which points will this line cut this line? Then you will have to write this as the answer. But in this question, no, you don't do that. When they ask you to solve, you just write x equals to what, y equals to what. This is one pair of answer. X equals to 2, y equals 2. This is another pair of answer. Okay, meaning to say you cannot swap these two around. You cannot say x equals to when x equals to -1, y equals to 2. When x equals to 2, y equals to 4. You cannot do that. These two are like a pair, okay? They are like a coordinate pair. These two, they are coordinate pair, so you cannot swap them around. So you have to be very clear about this. Now, some of you may be wondering how I get this y value after finding x. Very simple, you sub this x value back to either this equation or this equation, okay? Now, I choose to sub it back here because it's so much simpler, no quadratic term. So -1 you put here, minus times minus is plus, so it's 1 plus 4 giving you 5. Same here, put 2 here, -2 plus 4 give you 2. Alright, that's how you do it. Now, as you can see just now, when we have linear equations, okay, we can solve it using algebra. And also I showed you just now, we can also solve it using graphical method, right? Graphical method. Remember? So where it cuts, this is the y value, this is the x value. Now, for linear and quadratic simultaneous equations, you can do the same as well. Meaning to say that you can plot on a graph paper and then you get this answer. Okay, so this is the working, okay, from a Sec 3 A Maths book. Okay, as mentioned, we are bringing some Sec 3 topics down to Sec 2 so that you will have an easier time next year. A Maths is compulsory for everybody next year. Okay, so you need to study this and you will come out in your exam also. Okay, this particular topic that I'm teaching you now. So please make sure you understand. Okay, listen again. When I have a straight line and a curve equation, I can either choose to solve it simultaneously using algebra. Okay, this is algebra. Alright, and I get the answer, these two answers. Or what we're going to do next, right, is to solve it using graphical method. Now, how do I do that? Very simple. You plot the graph, the curve. Okay, I'm not going to do that because I have many other things to do with you. I just tell you roughly. Then after that, we'll do the actual question. You plot the graph based on a table of values. Okay, you put a cross, then you curve, use your curve ruler. You draw this. That is this curve, y equals to x squared minus 2x plus 2. Okay, this curve is this curve. That's the red curve. You do the same for this straight line. Okay, draw a table of values, the box, and then you choose two values that are here. Okay, the x values that are here, and then you find the corresponding y value, and then you join the two lines together. The point where it intersect, that will be your answer. Now, I want to show you this. Do you notice just now I mentioned that this -1, 5 is one point where this curve meets this line? Okay, so this is -1, 5, and 2, 2 is another point. 2, 2 is another point where the curve meets the line. So 2, 2 is another point. Alright, so you have to understand that the point or points where the curve meet the line is actually the solution to the question. Meaning when you solve this x value, solve this one, right? This x value here, this is -1. When you draw a dotted line down, this will be -1. When you draw a dotted line down, this will be 2. Okay, you need to understand this, otherwise you won't know what's going on later. Now, if you can't understand, just feel free to rewind, or you can WhatsApp me to ask questions. Now, I'm going to something more profound now. So please listen carefully. Now, it's very easy to ask you to draw a graph like that, then you draw a line like that, then find out where they intersect. And then you get this answer: x equals to -1, x equals to 2. That's very easy. Okay, but if now I have to ask you to work backwards, if I have to ask you this question, let's say for the earlier part A, you've already drawn this curve. Imagine this is a graph paper, okay? You've already drawn this curve. Now, maybe you think about it. What do you think is this value here? What is the y-intercept? Just by looking at this equation. Okay, you can pause the video and think. What do you think is the y-intercept? Okay, the y-intercept, to find y-intercept, you let x equals to 0, right? When x equals 0, you cover this up. You will end up with 2. Correct? So when x equals 0, this is 0, this is 0, so y is just 2. So this is 2. Just trying to tell you, because we've just done curve sketching, right? So you need to be very proficient in identifying the y-intercept. Now let's move on to the main thing that I want to go through today. This is the difficult one, okay? Which you will see, actually it's a Sec 3 topic, but we will test you in Sec 2. By drawing a straight line, the question says, by drawing a straight line to the graph. What graph are they talking about? Now, I mentioned just now, this is part A. This is the later part. Alright, so when they refer to the graph, they are talking about this graph paper that you have already drawn. Let's say this is a graph paper. You have drawn this graph already. Plotted this graph and drawn everything already. Now they want you to solve this equation. Now when they phrase the question in this way, you cannot use your calculator and use the algebra method that we discussed and then solve for x. You can't do that. Okay, so how do you use a straight line and then solve this equation? Now, the trick is this. Remember just now, this simultaneous equation combined with this simultaneous equation, okay, when you combine them together, you can actually get another equation of equivalent form to this, okay, that will help you to find the value of x. Alright? Okay, I repeat. Just now, when we want to solve this using algebra, we actually combine sub 1 into 2, combine these two, and then we minus x minus 4 on both sides, plus x minus 4 on both sides, and then we end up with this. Now, these two equations are equivalent, meaning they are the same. They are the same form. You solve this, you'll get the same answer. Okay? Now, we are going to use this principle. Right now, they are trying to ask you, what two simultaneous equations are? What two simultaneous equations, right? When you combine already, you can actually get this thing. So we are actually working backwards now. Okay? Now listen carefully. Which means that you need to get this equation on the left-hand side. I call this the left-hand side. This one, the right-hand side. Okay, sorry, it's a bit messy, but I think you can see what I'm writing, right? Okay, the left-hand side is x squared minus 2x plus 2. X squared minus 2x plus 2, which is the curve. Okay, you have already drawn the curve. So right now, you need to get back the curve on the left-hand side of the equation. When you do that, the right-hand side, right, your straight line equation will automatically appear. Now, what do I mean? I show you now, okay? Now, what do I need on the left-hand side? I need this x squared. Okay, let me write down the final destination here first. On my left-hand side, I need to get this curve which I've already drawn. I need to get this one. This is a curve, right? On my right hand side, I need to get a straight line. Okay, which I don't know what it is because in the real question, right, they won't give you this part first. They won't give you this part. They will just ask you to plot this and all that. This is just for me to help you understand that you're actually working backwards. Okay, now let's come back. I want to somehow manipulate this equation to have x squared minus 2x plus 2 on the left hand side. Right now I have x squared. Oh, I'm very happy. I don't have to do anything to this. Okay, but I don't have minus x. I minus 2x here. I only have minus x. So what must I do to get minus 2x? I need to minus x. I go and minus another x. Does that give me minus 2x? It does, because minus x will give me minus 2x. Okay, so if I do this on the left hand side of the equation, I must do the same on the right hand side of the equation. So I minus x here also. Okay, so I'm happy with this fella already. I have this, I have this, I have this, I have this already on the left hand side. I'm getting closer and closer to my curve. Okay, why do I need to get this curve? Because it's already drawn already. It's already drawn. Yeah, you cannot be moving towards another curve. No, we don't have. We are not going to waste time drawing another curve. No, we have to move towards the curve that we have already drawn. Now, let's look at this final number that we want, which is which is plus 2. Okay, we need to have plus 2. Currently, it is minus 2. From minus 2, how do we get to plus 2? We have to plus 4. Okay, minus 2 plus 4 is 2, right? Since we add 4 on the left hand side, we must add 4 on the right hand side as well. Oh, now we are very happy because this whole equation, by adding minus 4 plus minus x plus 4 on both sides of the equation, I have gotten this curve, meaning I have now gotten now I know that, okay, originally this is a line, these two, okay, originally they actually asked us to solve this and this simultaneously using graphical method. Yeah, it's just that after we sub in this into this and then we do some manipulation, then it became this. Okay, so what is the okay, sorry, not here. What is the straight line that you need to add to this graph? You need to add in, or you need to plot y equals to minus x plus 4. You need to plot this. Now, how do I plot this? Again, I told you before, in order to draw a straight line, you only need 2 points, and then you join the 2 points, you will get a straight line. Okay, now how do I choose? It's up to you. I like to choose 0. Okay, for example, the values you have here is from minus 2 to, let's say, 3. You cannot draw beyond this. Okay, you don't choose points that are outside of these two values. So you can choose minus 1, you can choose 0, you can choose 1, you can choose 2, you can choose 3, but you don't go and choose 5, 10 or whatever. It's not even in your graph, okay, or it's outside your range, so don't do that. So I like to choose 0 because when x is 0, I can just get 4, so I can get a point very fast. Alright, then I choose another value. I normally choose 2 units away on the right or on the left. So I like to work with positive numbers, so I choose 2. Then I'll get 2. 2, that will give me some point that is probably here. Somewhere here. Okay. Just a rough sketch. Okay, now you draw this line, right? You draw this line, label it. Okay, then you where it cuts the curve, that will be your answer. All right. So actually based on our working just now, sorry, it's a bit out. Yeah, it should be -1 and it should be 2. -1 and 2. See? Based on algebra, this is your answer. Based on graphical method, you should get the same answer. Okay, I hope you understand what's going on here. I know it's a bit complicated for some of you, but never mind. We will do the question and then hopefully you understand better. Now the first question we are going to do is your homework question number 10. Alright, it's found on page 140, question 7, which is this one. Question 7. Yeah, here. Okay, so this question says the variables okay, so the equation is this: y equal x squared minus 2x, and they're very nice to you. They've drawn this table for you. I know some of us have finished this question already, but I think we didn't have the time to discuss the last few parts here. So if you are okay with drawing the graph and all that, then you can just fast forward to the later part, alright? But I know there are some of you who don't even know how to plot the table of values and all that. So we will go through step by step, okay? Now, on a sheet of graph paper, use a scale of 2 cm to represent 1 unit on each scale. Now, this is 1 cm, this is 2 cm. Okay, I don't have a ruler, but you can use a ruler and measure. This 5 boxes here, right, is 1 cm. 5 boxes, 1 cm, 1 cm, like that. Okay, so how do you plan the scale? You want to use 2 cm to represent 1 unit on both the x and y axis. Okay, so how do I do that? Now it's good to always start with the x-axis. Okay, good to start with the x-axis. Now take a look at your table here. See what x values you have. Your x values range from -2 to 4. That means the smallest x value is -2, the biggest is 4. So maybe we start with 4. You try not to start at the edge. We see whether we have enough space. So I started here. 4. And actually in the beginning I don't know that this is where the x-axis is, but that means, right, it can be, the x-axis can be anywhere here, right? But I'm trying to see where's the starting point. So what I do is I think to myself, if this is 4, this would be 3, this would be 2, 1, 0. Then I check all the way to, what do they want? -2, right? -1, -2. Oh, so there's enough space if I start from 4 here. So what I do, I quickly draw the y-axis. Because I know that there is enough space now on the right and on the left to accommodate all my numbers. So I quickly draw a y-axis here. That's what I did just now. And then I quickly, not say quickly, I cannot draw this yet, okay? Because I don't know how high or how low I should go. So what do? I see again. I come back. What's the biggest y value? 8. Smallest is -1. So I start somewhere here. If I use this as 8, 8. This will be 7, 6, 5, 4, 3, 2, 1, 0. Then -1. Yeah, -1 is the smallest. Oh, so there's enough space. So I quickly draw the x-axis here. Then I can start to label my y-axis, label my x-axis. Okay, so once you have this, you are halfway there. All you need to do now is to plot point by point. Be very careful here. -2, 8. -2 refers to the x. X is -2, then 8 is here. Okay, so you see I mark a cross here already. In fact, I mark everything already. Please check your own markings. Alright, and there's one more point here. Okay, now let us go through how to use the curve ruler. Now I forgot to buy a curve ruler and the shops are all closed now, so this is a very old one. It's a bit melted already. Okay, I want to tell you that when you want to draw a curve, right? Take a look at the points first. You look at all the points. The points go like this. It's a happy face. Sec 2 is very simple. Either happy or sad face. Huh? Okay, so it's a happy face like that. So you may want to just take a look at your curve ruler and see which side is smoother or which side is more towards this curvature that you have for your curve here. Okay, and then you use that. Alright, and I don't know whether you notice, I don't know if you can see in your camera, no, your phone or your TV that I made extra markings here. Okay, so that I can get more accurate lines. Actually, I only did a few. Okay, if you want, right, you can actually make extra markings here. Meaning to say, right, you look at this point here. I don't know whether you can see. I actually used 0.5. Okay, the question didn't give me any point for x equals 0.5, right? But I myself pressed the calculator, okay, and I key in x equals 0.5 into this equation, and I found it to be this value. I put a dot here, and I don't mark with a cross. The crosses are reserved for the points that are given to you. Okay, for the points that you yourself use to guide yourself, right? You can use dots, just small little dots, okay? Because they are not supposed to be there. It's just to guide you to draw a more accurate curve, all right? Now, let's start. Now, how do I use the curve ruler? Now, when I look at it, I'm quite comfortable with this. I don't know whether you can see. Okay, you can't see. Okay, I'll turn this around. Okay, I think still can't see. Okay, let me turn on the light. I think you can see. Already. Okay, you can see one point here, and one point here. Okay, the guideline is at least 3 points. Okay, you aim for 3 points at one point in time so that your curve will be smooth. And notice just now I was massaging the curve ruler to really fit the curvature of these few points here. Okay, so right now you see when I put down my curve ruler, right, it more or less is falling into place where the plotted points are. Okay, so I'm going to draw the curve. Okay, I'm going to show you how exactly to do it. I normally will start from the furthest point. Okay, furthest point, you see, you don't have to use a lot of force when you try and shift your curve ruler and all that. You just, gently just touch, it will move, it will move because it's plastic, flexible plastic. Now, once you see the point there secured, okay, you just shift a bit, be gentle. Once you see the point there secured, right, you can actually just put a finger there, okay, secure it, don't let it move anymore. Just, see, just shift a bit. Okay, once it's there, okay, you press, you see this finger, and then the last one, see, I just shift a bit, okay, it's in place already. Then you draw using your pencil. That's all. Okay, now more or less, you see, more or less this has been bent to the curvature of this already, and you know that the curve is symmetrical, right? About a certain line, so you can just flip. You saw what I did just now? I flipped this over. Why? Because this part has already been bent or molded to the shape on the left hand side, okay, on your left. So I just flip it over. I don't want to do any more work to this fellow. You see, this fellow is crooked. Okay, now again do the same thing. Okay, maybe I turn this around, then you can see. Again, do the same thing. See, I didn't use any force, much force. Okay, it's there already. Okay, then just touch. Oh, it's there already. Then where's the other point? Oh, it's at the origin. Oh, it's there already. Okay, so what do? Apply some pressure here. Don't let it move. Apply some pressure. Apply some pressure. Okay, then you can draw the line. A curve, sorry. That's all. Okay. Now, you notice that I left this part. I didn't go on and draw this part. Why? Because I like to use freehand for this. And notice our hands, you see the wrist here? Okay, our body is built in this way. You take biology, you know. The curvature is like that. So you can turn the graph paper any way to suit the curvature of your wrist. Unless you are very good at drawing, very good at art, then perhaps you can do this. Alright? But for many of us, we tend to follow the curvature of our hand. So can you see this point here? I made a very small marking here. Okay, so that I know how low to go. Okay, so I will just follow this and then I'll go there. Oh, that's very bad. Yeah, that's terrible. Okay, so I erase. So if you are not a good artist like me, you have to erase. Get your eraser ready and then you erase and then you okay, follow. Yeah, like that. Something like that. Later I'll touch up a bit. Okay, then do the same here. Oops. Okay, and then go up. Yeah, something like that. Okay, this part is can be improved. Okay, can be improved. So I will just improve it a bit. Some of you are very good from this angle. You can draw and all that. Okay, go ahead. I am not very good, so I have to erase and do it again. Okay, this would be good enough to earn you full marks. Remember to label your curve, label your x and y axis. Okay, and all these markings that you have, your curve must pass through all these markings. Okay, which means to say that in Sec 2, for Sec 2 work, right, if you make any mistake, suddenly you have 1 point here or 1 point here, you know that you made a mistake in your calculation. It cannot be going up like that and then not smooth. Alright, so I always like to tell you to imagine you're on a roller coaster sliding down here. It should be a very smooth ride. Okay, now why did I choose to use freehand here and not this? Number one is, can you see that this part here is actually pretty sharp? So if I were to bend this and all that, right, definitely I won't be able to get a smooth curve. And you notice just now, I made additional markings here, dots, not cross, okay? So that I know exactly how low. You know, some of you will draw like that. Some of you draw like that until very sharp. Okay? Some of you may draw like that. So how curved is it? So by drawing 2 additional points here, you know for sure that, oh, this is the actual curve. Alright, so I hope this helps. Now let's move on to solve the question. You refer to your own book, okay? I don't have enough space to put the what do you call that? The book there. The book here. Okay, so we have finished part A. Now they ask you to use your graph in A for part B now to find the values of x when y equals to 1. Okay, y equals to 1. This is y, right? This y axis. So this is y equals 8, y equals 9, y equals 7, 6, 5, 4, 3, 2, 1. Okay, so all you need to do is from here, you draw dotted lines. Okay, you want to draw a straight line across, then label it y equals 1, that's fine also. And then you find the answer. Okay, so you go and get your own answer from there, meaning that you have one value here and one value here. So it will be minus, remember this side is minus, minus 0.4. Or, so from graph, is minus 0.4 or 2.1234. 2.4. Okay, so that's your part B. B part 1. Okay, now B part 2, minimum value of Y. Now Y values are all here. See 8, 9, 6, 5, 4, 3, 2, 1, 0. What do you want? The minimum. It means how low did your roller coaster go? You slide here. When you're here, you're like the 8th floor, 7th floor, 6th floor, 5th floor, and so on and so forth. Hey, the lowest that you can go is -1. Alright, so the answer is just minimum Y equals -1. Finish already. Okay, this is the answer. Now, what is the next one? Part C. State the equation of the line of symmetry. Notice equation of the line of symmetry. You know, line of symmetry is always a vertical line. It's a line that cuts this into half. Cuts this graph into half. So it has to be the lowest point here, the minimum point. Remember our curve sketching? So this is the line. Did they ask you to draw? They didn't ask you to draw. They only asked you to state. If they ask you to draw, then you just draw a line, vertical line like that down. Then you label here x equals to 1. Okay? But because they didn't ask you draw the line, so don't bother. Now let's go to D. By drawing an appropriate line in your graph. Okay? Take note. By drawing an appropriate line in your graph. That was what I went through with you in the beginning, right? Solve the equation x squared minus 2x equals to x. Okay. So how do we do that? Remember, this equation that they give you, okay, does it look like the one that you have? It doesn't really look like, but it looks quite similar, right? That means this is the combined form of two simultaneous equations. Your job now is to break this equation into two, okay? One of which must be this fella here. We are not interested in the y value. I see there's no y value here. We are only interested in the x value. So one side, normally we take it as the left-hand side. Okay, you do this method in a structured way. X squared minus 2x, you must have x squared minus 2x. Ayyo, this question is so easy. X squared minus 2x is already here. Okay, that means this is your y equals to whatever, and this is your curve, right? Which is already drawn, right? So they are asking you to break it up into this curve, and this must be it's a curve, and the question says line, right? So this must be your straight line, y equals to x. So your job, very simple, is to plot y equals to x. Okay? How do you plot this? Very straightforward. Draw a box like that. Okay? X, Y. Choose any value. What value to choose? I told you 0 is a very good number. When x equals 0, y equals 0, you get a number. You get a point straight away. Put the x here. Okay? This x is for this straight line. Okay? Now, you can choose any other value. I like to choose about 2 numbers away. You can choose 3 or 4 or whatever. Whatever number that you see here. Okay? Sometimes when you choose a number that is too big, right? Too big, the point may be out of the graph. Then you just change. When you press calculator, you will know. That's why I like to choose 0 and then just a few numbers away so that I stay within this region. Okay. 2, then it will be 2 lah. So 0, 0 is 1 point, then 2, 2 is another point. So what do I do now? I draw a straight line through this. Okay? I draw a straight line through this, and that's all. As long as my straight line cuts the curve, I'm happy already, because I just want to know where they cut. So this is my line. I need to label it. Y equals to x. And what is the answer? Because they ask you to solve, they ask you to solve this equation. Solve means you must find the unknown, right? So from your graph, okay, you cannot use calculator and then we'll do algebra here. We will give you 0. Like in your PA, some you got 0 because you use algebra. You have to use your graph. So show all these dotted lines. Show all these dotted lines. Oh, so the answer is 0. You see, you want the x value, right? It's 0 or 3. Finish already. Okay, so that's all for this question. Hope you are okay. Oh, already one period is over, just 45 minutes, but never mind. If you want, you can go and do something else. Then come back and watch another day or what, okay? This assignment is only due Sunday, or if you can't make it by Sunday, then Monday. Okay, no hurry, because I really want you to master this so that when the graph question comes out in the exam, when there's quite a number of marks, you get as many marks as you can, alright? Now this question is question 11 found in the extra worksheet that was given to you. If you don't have it, never mind, the question is here. Can you see the question? I think, oh yeah, you, oh, okay, can. Okay. You can see the question, yeah? Okay, the variables x and y are connected by this equation. Now, just by looking at the equation, you need to, you need to have this awareness what's going on. Don't do things blindly, yeah? You look at this, it is in the form ax squared plus bx plus c, right? See, yeah? If I write it as the highest power first, then second highest power, followed by the constant, the number, so this is your ax squared plus bx plus c. Okay? Your b is -5, your c is 7. Alright? Now, can you just by looking at this equation know whether it's a happy or a sad face? It is a sad face, right? Because your coefficient of x squared, the coefficient of x squared is negative. So it is a set phase, meaning it will have a maximum point. Okay, now, that's what you need to be aware of, meaning that later when you draw, right, you should be having a sad face and not a happy face or some other weird face. Okay, complete the table for this. Okay, I already completed for you. Alright, now draw this table. Draw the table. No, draw the graph. Oh, okay. Draw the graph for -3 and -3 to 2. Okay, and then they give you the scale here. They say use 2 cm to 1 unit for the x-axis. Okay, so I always tell you, you look at the x-axis first. See where it starts and stop. So -2. Actually, I've already drawn the thing. I've drawn the thing already, but I just want to tell you how to do it. Let's say I start here. I start the x equals to 2 here. See, x equals to 2 is the maximum value, right? 2, then it be 1, then it be 0. So if my 2 starts here, okay, my y-axis will be here. I double check and see whether there's enough space both on the left and on the right. Alright, on the right there's enough space. I'm very happy. On the left, I need to go all the way until -3. -1, -2, -3. Wow, plenty of space. Okay, so I'm okay with this. Okay, I'm okay with this. Right now, I need to find out where to draw this. So after that, right, I can straight away draw this y-axis. Straight away draw the y-axis, label it y. Alright. Now the next thing I need to know is how high or how low should I draw this x-axis line. Okay. So I go and check. Okay. The y value, the smallest value, wow, -15. Biggest value is 9. Okay, then I take a look at it, right? I actually find out that I have no choice but to draw until the maximum here. 9, 8, 7, 6. Okay, so this question not say very well planned. Okay, not your fault. Wait 1, 2, 3, 4, 5, 6 or 7, 7, 8, 9. Okay, so you label all these. So you've done your job already in terms of getting the scale correct. Okay, make sure you have labeled the x and the y. And And you see, I immediately label the curve here. I know it's somewhere going to be around here. Okay, now, next you go and plot each of these. -3, -5, x equal -3, y equal -5. You put one cross here, then you put one cross here, put one cross here, so on and so forth. Then you get all this. Okay? Now, again, let's try and do this together. Okay, take a look, take a look. This curve is a bit, or this question is a bit not so well planned because if I were to draw this, right, I've actually drawn extra points here, okay, to guide me. I don't know whether you can see. I darken it now. I darken it. Okay, now. Can you see that these extra points will actually guide me in drawing a smoother, more accurate curve? Okay, now how do I do this now? I use my curve ruler and then I shift here, shift there to see which is the correct match. Okay, here, then I draw here. Okay, you see how it's being done. If things are done correctly, you shouldn't have much problem drawing a smooth curve. Alright, so let me see. Did I miss any point? No, then I draw the way, where is it? Here. Okay, then I remove this. Oh no, miss a bit. That is very bad. Okay, but I wouldn't know that I have missed this point if I hadn't drawn this point. So it's good to have this point around. Okay, certain things it's good to use freehand. It's good to use freehand for those of you who are good in freehand. You don't have much problem, then you can just use your freehand. Okay, now my point ends here, you see? My point ends here. So what I need to do is I start with this point on my right, right finger. I press here, and then here, and here I extend a bit. Okay, I try to reach for more points all the way to here. Okay. Okay, then I join with a straight line. Not straight line. I join with a curve. This curve is alright. Okay, again down here, I'm going to use freehand. I know it's going to go up a bit and then come down here. Okay, so this is my curve. I need to touch up here later. Okay, come. Let's move on to the next part. I've already labeled the graph. What do they want from us? They say, hence solve 7x squared. No, 7, what solve? Part 3, solve 7 minus 5x minus 3x squared equals 0. Hence, hence means using the earlier part, right? Oh, so indirectly, they are telling you, hey, after drawing this graph, right, you need to use this graph to solve this equation. You cannot use algebra. That's what they're trying to tell you when they say hence. Okay, now let's take a look. You know that this that they give you is a combined sort of like combined simultaneous equation. Two simultaneous equations combined into one equivalent form, right? Okay, so let's take a look how to separate this into what you want. Oh, but then you take a look. Oh, so happy, they are so nice to us. It's exactly the same, which means that this is your curve. Then you don't have to add or minus or divide or do anything, no need. Oh, which means that this must be your y equals 0. Your y equals 0 is a straight line, right? A straight line. Okay, so all you have to do is to plot y equals 0, this straight line. Now where is y equals 0? This is y equal 9, y equal 8, 7, 6, 5, 4, 3, 2, 1, 0. So they actually just want these 2 points. Then you just give it to them. Okay. So what they want is the 2 points. Solve means you want to find the x value, right? So what are the x values from the graph? From the graph, it is minus 2.55 around there. Minus 2.55, and 0.9 around there. Okay, yeah, so that is how you do this question. Now for the next part, on the same axis, draw the line y equal to 2x. Oh, so now they are still being very nice to us. They asked us to draw this line. They didn't ask you to find this line. In the previous question, you had to find some lines, right? This one no need. Okay, so they ask you to draw this line, then we just draw for them. Just draw for them. This is considered a very simple thing to do. Choose any 2 points, okay? From minus 3 to 2, you can choose any of these x values. I like to choose 0. Put 0 here, this 3. So 0, 3 is one of my point for the line. And if I choose another point, let's say I choose 2, then this will be minus 1. So 2 minus 1 is my other point. Okay? Draw a straight line through. Wait. Did they tell me draw from what to what? Oh, yes, they did. They asked me to draw from minus 3 to 2. Meaning to say, I cannot anyhow draw the length that I like. I cannot just happy draw like that, right? Oh, cut, I'm happy already. I cannot do that. I cannot say, oh, cut already, I'm happy. Oh, cut already, I'm happy. Cannot. They want me to draw from minus 2 to 3. So I need to go all the way to 3. Okay, so take note of such instructions. See, they want to draw from minus 3 to 2. Wow, then I draw beyond, Just now I drew beyond, cannot. They would minus your mark. So what the examiner will do, right? Okay, sorry, because I use pen. If you are done yet, you have to erase it. The examiner will do this, and then they will minus 1 mark here. Okay, because you didn't follow the instructions here. Alright, now they say, hence solve the equation, this one. Oh, how to do that? Before we do that, we have to label the equation. Minus 2x plus 3. Okay, so labeled already. Curve labeled, straight line labeled. Okay, now, hence solve this one. Oh, how do I do that? This is the part that I was talking about just now. Alright, you see? Now, does this 4 minus 3x, whatever, right, look like the original curve that is drawn? No, it doesn't, okay? So, you have to make this, put here, 4 minus 3x minus 3x squared equals 0. You have to make this left-hand side somehow become this curve. 7 minus 5x minus 3x squared equals something. We don't know what that thing is, okay? How do we do that? Okay, so you do it step by step. Always start with the highest power, which is the x squared term. I know they wrote the 4 first, right? Don't bother. Okay, start with the x squared term. Do they match? Oh, they match. That means you don't have to do anything to this. Leave it as it is, okay? Now, take a look at the next highest power, which is x power 1. Minus 3x. How do I get to minus 5x? I have to minus 2x, right? Minus 3 minus 5, you press your calculator. No, sorry, minus 3 minus 2, you press your calculator, it will be minus 5. So if I minus 2x on this side, I have to minus 2x on the other side. Okay? Now, we are done with this. We are happy. Okay? Now, let's take a look at the number. Number, I need a 7, but I now only have 4. So, I must plus 3, right? If I plus 3 here, I must plus 3 here. Okay? Oh, now this has become 7, so I'm happy. So we have settled everything on the left hand side. Now this is your y equals to whatever, which is your curve that you have drawn, okay? And your right hand side, this is your y equals to whatever. This is your straight line. Isn't this straight line this straight line? Aren't they the same? Oh, so the question has guided you to actually break it up into what is required. So what you need to do now, they say hence solve this equation. Solve means you need to find the x value, right? So from graph, what is your x value equals to? You just find out where the curve cuts the line, and that's your answer. Okay, so in my in this graph of mine, right, I have about here, which is minus 1.1275, minus 1.75. Okay, and how about the other one? The other one is here. Okay, so if I were to draw down a dotted line and see what's the x value, I'll get 0.8. Alright, 0.8. Okay, now these are the two answers based on my graph. Alright, now I am recommending, or I'm suggesting something. You can actually use your calculator, right? You see, they ask you to solve this. This is the original one. This question asks you to solve this, right? You can actually press your calculator. Remember, always start with the x squared term. So it's minus 3 equals minus 3 again, and then 4. You will find that you get 0.75. Okay, don't know whether you can see 0.75. Okay, whereas I got 0.8. So pretty close, right? Now, what's the other value? Minus 1.75. Oh, almost. In fact, it's very accurate. It's very accurate. So, my graph is drawn pretty accurately. Not perfect, but pretty accurately. Now, what some of you can do is, if you are very fast and you know what I'm trying to hint to you, what you can do is, next time, when they ask you to solve this equation, right, you know that you can actually use calculator to get the answer, right? You know that you can actually use a calculator to get the answer. After drawing the line is normally quite accurate. Line is normally quite accurate. After drawing the line and the curve, okay, you can actually adjust. Meaning you know that the answer must be minus 1.75, right? You mark here 1.75, then you draw a dotted line up until it hits the line. Okay, then if your curve is a bit out, for example, just now, if I blur, I go and draw a curve that is like that. If I draw like that, right? Oh, okay, a bit exaggerated, but if I draw out, then you know that, actually, it didn't cut the curve here when this is actually supposed to be the answer, right? But I didn't cut, it cut here. That means your curve must be wrong. Okay, you must have drawn your curve inaccurately, you know what I mean? So what you do, right, is in such a situation, because you are working backwards to find out what's the answer, you can actually now, you know that it's actually supposed to be here. Your line normally is very accurate, unless you mess up your set 1 work. Okay, so you redraw and make sure that your curve passes through here. Then you will have a very accurate answer, and the examiner will give you 2 marks. Yeah. Okay, so that's something you can do. Alright. Okay, now for the last question. Wow, it's already 1 hour. Okay, never mind. I think last question is pretty straightforward. What did they say? They say this is the equation. They ask you to complete this. I already completed for you. Please double check the answer is the same as mine. Then they ask you to draw this graph. Okay. Now I won't go through how to plan this scale anymore. I think more or less you should know we've done it twice. Hence solve this or whatever. Okay. So I'm going to draw this curve. Okay. So notice just now I bent my curve ruler. Okay. It's a bit out of shape now. Okay. So in the exam, right, and press for time. So I need to choose which side I want to use. Is it this side or this side? This side looks so crooked, right? I don't want to spend time massaging it, so I will go for this side. Although this side, you can see due to time, is a bit like melted. Okay, the plastic has like deformed. Okay, but never mind. It's still better than the other side. Okay, take a look. Where should I start? I know that this is the minimum point. It has to be the minimum point because you take a look, it's like a mirror image, mirror image, mirror image. The line of symmetry should be here. Okay, if they ask you to draw a line of symmetry, it should be here. Okay, now I use this part here. Alright, I use this part here, and I just bend a little bit to fit the curvature. Yeah, shift a bit. Then I push a bit. It fits already. It fits already. I have 3 points. Then now I see I want to try whether I can do it one shot. Oh, I think I can't. Never mind. I'll just draw 3. Okay. So that's how I do this part here. Now I flip over. Oh, for this side, pretty straightforward. They only want these 2 points. So what do? I just join them up. Okay. Now, this part here, I will use freehand. Yeah, I thought I labeled, but I didn't label. Okay, never mind. I will now use freehand. Okay, and then I turn the paper. I will now use freehand again. Not very good, but never mind, we move on. It should be a bit flatter. It's a bit too sharp already. You imagine you're sitting here and then you will hit your bum here and it'll be quite painful. So it has to be smoother. It has to be smoother. That means this part has to go down a little bit. Okay, so when you erase, you have to erase properly, but still you have to be able to see a little bit of what you've done previously, so that you know that, oh, okay, now I'm going to go down a little bit more. Now it's smoother. Can you see that? It's not so sharp. You land here, right? You won't feel that much pain. Okay, that's something like that. Okay, let's move on. Not perfect, but can be improved later. Okay, don't want to take up too much of your time. We focus more on the solving. Now, I've already labeled the graph. I labeled the x-axis, the y-axis. Let's do the question now. Sorry, there's the wrong question. I've done this part here, I've done this part here. Hence, solve the equation this. Okay, let's see what it is all about. Part 3. Solve this x squared plus 6x plus 9 equals 0. Now, again, this must be a combined version of the two simultaneous equations, right? Now, compare this with this. Oh, again, they are very nice to us. Very nice, huh? The setter is a very nice setter. So, this is your curve. This has to be your line. So what is the line you need to draw? Y equals 0. Again, y equals 9, 8, 7, 6, 5, 4, 3, 2, 1, y equals 0 is this line. Oh, but this line already drawn for you. So this is the point that you want. And what's the x value? Remember, when they ask you to solve this, right? Solve means find the unknown, right? What is the unknown here? X. So we are not interested in the y at all, no? So don't give me any y value. I'm not interested in it. They only want you to find the x value. What's the x value? Minus 3. Okay, minus 3. You need to draw all this. I just darken it for you. Okay, now this is minus 3. Finish from the graph. So don't need to do any working. Finish. Now what's the next thing? Hence solve the equation x squared plus 6x plus 7 equals to 0. Okay, again, this is a combined form of two simultaneous equations, the equivalent form of two simultaneous equations. Again, you can press calculator, get the answer, and then work backwards, alright? But But don't show any working here, okay? Do not show any working. If you want to show working, then show it in pencil somewhere else. After that, then you erase, okay? Now, let's try and do this. I know that I definitely need the curve because it says hence. Hence means I need to use the graph. Okay, so I need to always have the end in mind. I want the curve. This curve. It looks so similar. Okay. Don't write anything here because you don't know what is here. You don't know the line. That's what they want you to draw and then later cut this curve and then you get the answer. Okay. Now, always start with the highest power. X squared. Oh, x squared already. I'm very happy. How about 6x? Oh, 6x already. I'm very happy. So the only problem I have is this fella. I do not want 7. I want 9. So how to get from 7 to 9? I plus 2. If I plus 2 on the left, I must plus 2. Oh, this will give me 9. Very happy. This will give me 2. Which means this is your curve. This curve, okay? Not any other curve. It must be this curve. Must be this curve. Okay. How about this? This is my line. Y equals to 2. How to draw y equals to 2? Do you need a table of values? No, don't be silly. Don't do this. Don't do. You're wasting time. Y is equals to 2 is a line that is horizontal. Okay, y9, y equals 8, y equals 7, 6, 5, 4, 3, 2. So 2 is here. Alright, you draw a line across. Just draw a line across, and that's your y equals to 2. Label it. Must label, must label. Okay, but the question wants you to solve this, right? What's the question again? Hence solve this. So you need to solve it. You have not solved it yet. You've only found that, oh, I need to plot this line or draw this line. You've drawn the line, but you have not answered the question. The question says solve. Solve means you need to find x, the unknown, the unknown. And because this is a quadratic equation, there should be two answers. Two answers, okay? So what are the two answers? Where they cut. Where they cut. Alright? Now let me demonstrate to you what I meant just now in the earlier question using the calculator to help you work backwards. Okay, now don't press this, okay? Don't press this. Don't press wrongly. We must work smart. You don't press this curve that you have found. If you press right, you will get minus 3. Confirm you get minus 3 1. You don't believe, you go and press the calculator. Because this is where the curve cuts the y equals 0. Where the curve cuts y equals 0. Confirm is minus 3. You don't believe, you go and press this. Okay? What you need, right, is sorry. Don't about this one. This one you go and press, right? You go and press. Sorry, this one. This one, you go and press 1, 6, 9, right? You will surely get minus 3. Okay? So you need to press this. You need to press 1, 6, 7 because this is the equation that they want you to solve. The equation that they want you to. Don't press anything else. Press 1, 6, 9. You will get minus 3 and you will get 1. Did I press wrongly? Oh, sorry. I see wrongly. Sorry. Here. Sorry about that. Yeah, here. I saw this wrongly. Okay, not this one. 1, 6, 7. Sorry. That's the equation they want you to solve. Okay, hence solve this. Sorry for the confusion. 1, 6, 7. Okay. Yeah. You get minus 1.58. So you know that later your answer, right? Minus 1.58 around there. Maybe your answer should be 1.6 based on the accuracy of this graph. It should be around this minus 1.6. Okay, you round off around there. And then the other answer should be minus 4.41. Okay, so it won't be so accurate. You write this answer down here, right? Examiner will know you cheat. Okay, so you don't write down this. you write minus 4.4. So you work smart. So these two answers definitely will earn you the full marks. Let's check how accurate Mr. Lim's graph is. Okay, now this curve, cuts this line, y equals 2, okay, solve this simultaneously. They will cut here, right? Okay, my answer is minus 4.45. Okay, minus 4.45. Pretty close. I'm happy with it. I don't need to make any change. Okay, they will give you allowance. Okay, don't do like me. You just use a pen and do it. Okay, so it's minus 4.45, which is very close to the required answer, minus 4.4. So you get a full answer. You get a full marks. Okay, now the other answer will be minus 1.5. Okay, my answer is minus 1.5. If I'm not happy with these, then what do? I will erase. Okay, so this is how you get full marks in the exam. You know that is minus 1.6, right? Okay, so you draw minus 1.6. That means your curve must pass through here. Okay, so what do? You erase the so-called not accurate one already. So now you redraw a little bit. Make sure this curve passes through here. You see? Because your curve must pass through this line. So once you do this, full marks. Mr. Lim just now, most probably also full marks. They will give an allowance. But if you want to be very, very accurate, so that's how you do it. Understand? And you saw just now, I didn't just erase here. No, I erased this part. Because if you just erase here, it will look very strange. Your graph may look like that. Then suddenly, you will try and fit something. Then it become like that. There'll be like a bump here. Okay, so don't do that. You erase this whole section and then you redraw like what I did just now. Okay, use the curvature of your hand to help you. Okay, you can shift this around and all that. Okay, I think that's all for today. Sorry I took up so much time. 1 hour 15 minutes, 17 minutes. Okay, thank you. Have a good weekend. This is only due Sunday if possible, not possible Monday, not possible Tuesday. Okay, thank you very much.